Friends, today we discuss about some of the questions from D and F block elements and which are appeared in the previous entrance exams and also which are very important. Let us see the first question and see in which oxidation states copper and iron undergo disproportionation in aqueous solution. Coming to the first option, either you consider copper plus 2 and Au plus 2. They are not actually undergoing any change or any disproportionate any reaction in the aqueous solution. Coming to plus 3 is not existing for this particular copper and Au. Coming to plus 4, yes, for copper and iron also plus 4 is not stable, plus 4 doesn't exist at all. But coming to plus 1, copper and iron doesn't exist in aqueous solution, undergo disproportionation. What is disproportionation? You might be knowing this, the simultaneous oxidation and reduction of an element in a particular chemical reaction. Now, simultaneous oxidation and reduction. In what way? This copper plus 1 and Au plus 1 undergoing simultaneous oxidation and reduction. Let us see. According to this particular equation, look here, 2Cu plus 1 you take. This undergoing this disproportionation, it is easily converting into copper plus 2 and copper in aqueous solution. How can you say that this copper plus 1 doesn't exist in aqueous solution? Equilibrium constant you write for this, then it will be copper plus 2 and copper plus 1 square. This particular reaction equilibrium constant value coming to be 1.6 into 10 to the power of 6. See, such a very big value, 1.6 into the power of 6 means what? Copper plus 2 concentration is this many times greater than copper plus 1. In comparison to this particular copper plus 1, the concentration of copper plus 2 is very high. Therefore, we are concluding that copper plus 1 doesn't exist. If it exists, very trace amounts it may be existing in the aqueous solution, easily undergoing oxidation to copper plus 2. Similarly, you talk about Au also. Consider in the case of Au, suppose you consider Au plus 3 you take. What I am saying, Au plus 1 is that no, right? Au plus 1 only we write. Au plus 1, 3 Au plus 1, similar way, take it. This is undergoing oxidation, plus 1 undergoing oxidation to plus 3, and again this is what 2 Au. Au plus 3 to Au. Let us write this particular equilibrium constant for this K. Au plus 3 and followed by Au plus 1 cube. This particular equation equilibrium constant value is found to be 1 into 10 to the power of 10. See, imagine it's a very big value, means in aqueous solution Au plus 3 concentration is 1 into 10 to the power of 10. We can say it is millions and billions in comparison to Au plus 1. Au plus 1. Therefore, here copper plus 2 concentration and Au plus 3 concentration both are actually many more times greater than either you take copper plus 1 concentration, Au plus 1 concentration in aqueous solution. From these two equilibrium constant values, we can conclude that copper plus 1 and Au plus 1 are not existing in aqueous solution, because in the case of copper plus 2 is stable in aqueous solution, and in the case of Au plus 3 is stable in the aqueous solution. Therefore, copper plus 1 and Au plus 1 undergoing disproportionation in aqueous solution. We can say that they are not existing in aqueous solution. Therefore, option D is correct for this particular first question.